All right, welcome to Chapter 7, Section 1, called Congruence and Transformations. This is for Math 8. So a couple things you should see on your screen here. The first thing you should see is your due date. I don't see that on the teacher preview, but you will see it on your screen. So the attempts is the second part here. Number of attempts always is unlimited, meaning you always have unlimited tries for your tests, homework, and quizzes. The number of questions, it just lets you know how many questions there are on this particular assignment. Grading policy is best score, so whichever attempt is the best one is the one you get to keep. Partial credit is always enabled, so if you answer 1 of 9 questions correctly, then you get credit for 1 question, or however many you've answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. So if I click start, what this means is down here in the bottom right corner, you will see the submit assignment button. I know I don't see it on my teacher preview here, but you will see it on your student screen. So before you leave this screen, I'm not talking about going to problem, but before you close this screen or close your computer, you click submit assignment. Otherwise, Alex is going to assume that you want to leave this attempt open, and it's going to lock you out of all of your other assignments. Remember, you have unlimited attempts. There's no reason to leave this attempt open. As long as you have green check marks up here, you've actually clicked check on things, then it will save your progress, and clicking submit assignment won't make you start over. It's just going to start you back up where you left off. So big reason, it won't lock you out of assignments if you click submit assignment. The second big thing of clicking this button is that it's going to affect the grade book. So your teacher can actually see what you've been doing. Before you click that button, basically your account's on pause. We don't get to see anything. Over here we have explanation, example, and message center. So explanation quite literally tells you you're going to lose your question attempt because it's going to give you the answer to this question here. So it's not going to give you the answer unless you come type it in. The example will give you a very similar example to what we are looking at, kind of explain to you what you need to do. So you can go through, you can even click on more. It's going to give you a little extra pop-ups, things like that. And then it'll show you how to type in your answer. Once you're good, you can click the X button here. You can click example for another example, and you can message your teacher directly from the screen. All right, so we're starting to look at congruence here, and we're going back to transformations. So all of section 6 is about transformations. And you can see over here on the notes page, I have these 3 transformations kind of shown. These are the rigid transformations. And what rigid means is I'm not changing the size or the shape of a figure. I might simply move it around a coordinate grid, or in this case it's not a full coordinate grid, but around the grid paper. But I haven't changed the size or the shape if it's a rigid transformation. So the 3 that we're looking at, we can reflect an object, so we kind of flip it over, or we can think of it like a mirror image. If you look in the mirror, it's you looking back at you, but you're backwards, right? So it's the same image, just backwards. A translation is a slide, so I can slide it, up, down, left, or right. And then I can also rotate an object. So I can rotate it clockwise, going with the clock, or I can rotate it counterclockwise, going backwards. So there's just these 3 things can happen, and it doesn't change the size or the shape of the object. So when we ask if an object is congruent, we're asking, is it the same size and shape? Not general shape, exactly the same shape. So it can't just be 2 general triangles and have that work. They have to be exactly the same size and shaped triangle, or whatever figure we're looking at. So if we look at these 2, it looks like I rotated this guy. So he just kind of flipped over. It was laying down, now it's standing up. And I just want to make sure it's 4 long, it's 3 wide. I have 4 tall now, but I can still think of that as long, and 3 wide. So yes, that guy is congruent. They are the same exact rectangle, it just was flipped over. These are not even close to the same shape, so I'm just going to click no, because that's the first thing we should be checking. Are they even the same shape? These are both triangles. We just need to make sure that they're the same. So the easy way to do that with triangles is look at the base. So it's 4 and 4. And I have 1, 2, 3, 4 tall, 1, 2, 3, 4 tall. So they have the same base and height. It just looks like I scooted one either up or down, depending on which one you're starting with. These are the same shape. They're both circles, but they're not the same size. So these are not congruent. So we're just kind of testing those those definitions there a little bit. All right, we're going to look at a figure and kind of statements about a translated figure. So remember, translating is we're sliding it up, down, right, or left. So we're going to translate the figure 5 units left. So I'm going to click on the figure. You can see that the little pointer finger changed to kind of a grab. And I'm going to go 1, 2, 3, 4, 5. Boom. And I'm going to click to let go. So then we're going to decide if each statement in the translated figure is true or false. So down here, the final side lengths are the same as the original lengths. Well, I didn't do anything to it. I just moved it over. I didn't change the side lengths at all. So that would be true. Remember, a translation, reflection, or rotation doesn't change the figure. It just moves the figure. So anything down here dealing with change is going to be a no. If it's telling us that it is changing. So the final side lengths are the same. That's true. The final angle measures are the same as the original angle measures. Well, that's true. They didn't change. They just moved over. If two sides are parallel in the original figure, then those same two sides are parallel in the final figure. Well, that's definitely true. I know we haven't actually stated that yet, but if they were parallel to begin with, they're also going to be parallel, to end with. Even if I rotated it, those same two sides would still be parallel. They would just be in a different direction, but they would still both be parallel. So that is true. The original figure and the final figure may not be congruent. Well, that's definitely not true. The original and the final figure will be congruent. All we did was translate it. We just scooted it over. So that's definitely going to be true. Or false, I'm sorry. All right, so this next screen, so this one requires us to be on Alex a little bit to test it out anyway. So in each part, translate the solid figure exactly onto the dashed figure. If it's not possible, click not possible. So we want this one to come over here, and it's just asking us to translate. So this looks more like a reflection, doesn't it? Meaning that I flipped it over. It's backwards. So that's not a translation. So it's not that it can't be transformed from this guy to this guy, but I can't translate it. So I'm going to click not possible. So then this one, I'm going to click the blue one to let me. I'm going to scooch it over. And that one I can translate. I can just scooch it right on over. So I'm going to click check, and we're going to keep moving here. All right, so this one we're going to look at reflecting a figure across the y-axis. And you need to pay attention to which axis it's asking you to reflect across. Because what you're going to do is you're going to use this tool over here. Y-axis, that's vertical. So I'm going to click on this tool, and then I'm going to click on the y-axis, and it's going to flip it for me. So that's how you flip it. If it said x-axis, that would have been horizontal, and I would have clicked this one so that I would have had the horizontal line and it would have flipped it across there. So make sure you're paying attention to which one it's asking you to flip over, because that's going to affect your final answer. It's not going to affect these answers. They would still be true or false either way, but it's going to affect whether or not you get it right or wrong when we click check if you followed the directions. So just pay attention. So again, reflections don't change anything about the picture or the image. It just moves the image. I know it's a mirror image, but they're still identical to each other. Okay? They just are reverse or opposites, I guess. But they're still the same figure. So the final angle measures are the same as the original angle measures. That's true. The final side lengths are shorter than the original side lengths. Well, that's not true. I can definitely see that these guys are the same length here, and they're both 2 units apart here. So that's not true. They're not shorter. That was a change. Nothing changed. The original figure and the final figure may not be congruent. Oop, that's may not. That's not true. If 2 sides are parallel in the original figure, then those sides may not be parallel in the final figure. So be careful. They love to throw this word not in here. So if they were originally parallel, they will still originally be parallel or still be parallel in the final figure, not originally. So they threw may not a couple of times there. So we just need to make sure we're paying attention to that wording because they're trying to throw us off a little bit with that guy. All right, so now we're going to do that same thing we want to try to reflect the image, the blue image, onto the dotted image. So if I want to reflect, it looks like I'm reflecting this way. Let's try it. So I'm going to go like this. Well, that's not quite perfect. That wouldn't work. I'd need to do more, and I don't think I could because it's only going to let me do one reflection here. So if I could reflect it again, I actually think that would work if I could reflect it 3 times, but I don't think it will let me. Every time I do this, it's one reflection that it wants me to do. So I'm going to go ahead and click not possible. On this one, I know I want to flip over the horizontal. There's a line in between them. So I'm going to click and it reflects right on top. So that top one was possible if I could use the reflection more than once, but it was only letting me use it 1 time. All right, so I think what we're going to do is look at properties of a rotated figure. So remember, there's rules for rotation as far as where the coordinates end up. For this one, we just get to use this really cute little tool here. So we're going to rotate 270 degrees clockwise. Pay attention to the direction it's asking you to go, clockwise or counterclockwise. So I'm going to go clockwise. That's with the clock, so that's this direction to the kind of the right. And 270, we always kind of divide it into 90s. So if I have 270, this is 90 going from one axis to the next. That's 90. That's 180. That's 270. So you just want to pay attention. You know, each turn you make is 90 degrees from axis to axis. And it's always going to be some kind of part of 90, at least for 8th grade. They're not going to do anything more complex than that. So then we're going to decide if each one is true or false. Remember, rotation is one of our rigid transformations. It doesn't change the size or shape. If 2 sides are parallel in the original figure, then those sides are parallel in the final figure. We've already talked about that. That's definitely true. Even though they're in different orientations, these 2 sides are parallel. They're still parallel here, even though they're going in a different direction. All right, the final angle measures are the same as the original angle measures. That's true because it didn't change. The final side lengths are shorter than the original side lengths. Well, we didn't change the size, so that's not true. The original figure and the final figure are congruent. Oh, that's true. Rigid transformations give us congruent figures. All right. So on this guy, we're going to see if we can rotate him. So we're just using the rotation tool here. So I'm going to click on this rotation tool and I'm going to see, can I rotate it to get to that figure? And it looks like I can. So I went 270 because we can see 1, 2, 3 turns. But I could have also gone just 1 turn counterclockwise. So here it is starting. I could have gone 1 turn counter backwards, and that still would have also worked. Either one would be correct, but you can see the arrow direction on where I'm going. So this is going kind of backwards on the clock, or I could go forwards on the clock. So this one, if I go this way, these are different sizes, right? I can even see that. One parallelogram is much smaller than the other, so I'm going to click not possible. All right, 2 more of these guys. So we're going to determine if figures are congruent and related by a sequence of transformations. So we want to know, how did we get figure A to figure B? And first, are they even congruent? Can we even do this? So figure A, I can see on here it's 1, 2, 3 tall. Figure B is 1, 2, 3 tall. It has 2 across the bottom. It has 2 across the bottom. 1 tall here, 1 tall here. And I can even look at the slope. I'm going to go up 1, 2 over 1, 2. Go up 1, 2 over 1, 2. So I can check all the way around. Even though it's a diagonal, I can just check to make sure that the slope is correct to get that line. So these are definitely congruent. These work. Which transformation will map figure A onto figure B exactly? So figure A to figure B. Well, it looks like I'm just moving down. And let's count how many. 1, 2, 3, 4, 5, 6, 7, 8. Why did I go all the way to the bottom? Where did I start? So I started at the bottom. I need to make sure I go all the way to the bottom of the figure. If I stopped here, that would not have worked. So I would have been shy a few units there. I want to go all the way to the bottom. So I moved a full 8 units down. So let's find the one that tells us that we're translating, we're sliding 8 units down. So I have translate and translate. So it's going to be one of those first two. The rest of these don't work because it's reflection or rotation. So I'm translating the figure 8 units left. Well, that is -8, but that's -8 units right or left. I don't want to do that. So I want to go down 8 units. All right, so for this one, and again, it looks like the exact same figure. I have 3, 2, 1, 3, 2, 1, and the slope is also correct because it's 2 to 2. I can go 2 to 2. So these are congruent. Yes, they are. Which transformation will map figure C onto figure D? So figure C to figure D. And this definitely looks like I'm turning. Hopefully we can kind of picture that. If we picture a little pinwheel here in the middle and I could spin it, this is rotating over to the right here. So C is rotating right to D. Well, if we think about a clock, am I going clockwise or counterclockwise? It seems like I'm going counter. I'm going backwards on the clock because I'm going from C to the right to D. So I'm going to rotate counterclockwise. So let's go down here to rotations. Rotate figure C clockwise, rotate figure C counterclockwise. So it's either going to be this one or none if this one's not correct. It does look like I'm only moving one 90-degree turn. So I do believe that this guy is correct. It's a little bit harder to picture this one without, actually getting to move it. But we can even apply the rules. I have -2, -2 over here. -2, -2. And if I move 90 degrees counterclockwise, I'm going to use this rule, which means I flip X and Y, and Y is going to become positive. So it's going to be 2, -2, like that. So the 2's would have switched spots, which wouldn't have made any difference at all. But the Y needed to become positive, which is now in the X position when I use this rule here. So if I look at this piece here, I'm going to have +2, -2. So that does, in fact, work with this rule. I can see that that is, in fact, what's happening. All right. We have one more question, I believe. Let's see. Okay, so answer the questions about figure A and figure B. So we need to figure out, are they congruent? So it's the same exact question, actually, as the last one. We're just doing it for one. But they may have more than one option. So we can see that these are boxes instead of it just being one little circle. Because the last one, if you were paying attention to the types of questions, these were circles, which means one of them would be selected. But now in number 9, we have a different type of question. They're boxes. So I can select more than one that's correct. So just pay attention to that question type. That's one of those things that we were practicing on the IABs when we were doing that all together, the question types there. So those practice state tests when we were taking a look at those. So are figure A and figure B congruent? So these look to be the exact same figure that we were just looking at. 3, 2, 1, 3, 2, 1. We have a slope of 2 to 2. We have a slope of 2 to 2. So that does look perfect. They are congruent, same size and shape. So now we need to figure out if these will result in the same figure. So one thing I want to do here, I'm going to steal this guy because this is a little easier to picture, I think, if we can actually kind of tweak the image and see what happens. So this says translate the figure A to the left 7 units. So I'm going to just take this piece and I'm going to go left 7 units. Oh, figure A, sorry, left 7 units. 1, 2, 3, 4, 5, 6, 7. And then I would do the same thing here, so it would end up landing on the same one. This one's going to be 2 units away. 1, 2, 3, 4, 5, 6, 7. And then this one's just going to be right here. So here's my first piece that it asked me to do. And then rotate it. And then rotate the result 90 degrees about the origin. So remember with this one, if I'm going 90 degrees counterclockwise, that's important. I'm going to go backwards about the origin. I'm going to take my coordinates, and this one, I'll just take this one. This is -5, 4. And because it's counterclockwise, pay attention to counterclockwise or clockwise when you're looking at your notes. I'm going to flip X and Y. So it's going to become 4 and -5. I just flipped positions. But then the Y coordinate needs to become opposite. So it was +4, now it's -4. So if I come down here and I go positive or -5, -4, that would be right here. That does not, in fact, work. That does not land in the right spot, even for that first coordinate. So I know it's not going to be this first one. So I'm going to go ahead and undo this guy. So now it says reflect A over the y-axis. So I'm going to reflect it over the y-axis. It's 2 away. So I'm going to go 1, 2. This one is also 2 away. This guy is 4 away. So I'm going to go 4 away this side and then 4 away this side. So here's the reflected image. And then rotate that result 180 degrees about the origin. Doesn't matter if it's clockwise or counterclockwise, 180 degrees, either way is the same thing if I'm going clockwise or counterclockwise. It really doesn't matter. So I'm going to take a look at this coordinate real quick. So this is -2 and 4. So whether or not I'm going clockwise or counterclockwise for 180 degrees, all it does, they don't switch positions on this one, they switch signs. So the 2 and the 4 stay there, but now it's going to be +2 and -4. So I'm going to come down here and I'm going to go, it's going to be +2 and -4. So this should be over here. So that second one doesn't work either. All right, so then we're going to have reflect figure A over the y-axis. Oh, dang it, I should have left that alone. There we go. Ooh, excuse me. And then translate 9 units down. Well, even if I go down, it's in the wrong position. This guy's kind of pointing up. This one's pointing to the left. So I know that's not going to work. So I know I'm not going to choose that third one. I don't even need to map it. It's not in the right position. Okay, rotate figure A counterclockwise 180 degrees. So remember, clockwise, counterclockwise, 180 doesn't matter. But I'm going to take a point here, and it's going to be 2, 4, and it's going to stay 2 and 4, but it's going to become -2, -4. So I flip both of them. So I'm going to go -2, -4. So it would land here. And then I would do the same thing. So I can actually, because I already know the position it's going to be in, you know what, is it going to be upside down? I think it's going to be upside down. Let's make sure. I don't want to picture this wrong. So 2, 1. So I'm going to have -2, -1. So -2, -1. And then this is 4. I'm writing too much on here. 4 and 2. So it's going to be -4 and -2. And then this is going to be 4 and 1. So -4, -1. So yeah, it flipped upside down like that. So it's upside down. And that makes sense. You know, it rotated. So it kind of turned over there. And then reflect that over the x-axis. Well, all that would do would move it over here. So it's 2 away. This one's 4 away. This one is 4 away as well. And this one down here is 2 away. So that would reflect it over here. So this turns out that none of these will work. So let's see if I checked them all correctly. Uh-oh, which one did I miss? Did I forget to check one of these? Are they not congruent to begin with? 1, 2, 1, 2, 2, 1, 2, 1. They are congruent to begin with. Uh-oh. One of these mappings works. So, which one is it? Which one did I make a mistake on? Okay, so I'm going to try this first one again really quick. 1, 2, 3, 4, 5, 6, 7. So that guy would land right there. If we moved it 7 units left, and then rotating it 90 degrees about the origin, so this would be -5 and 4. And this would change 4 and 5. Negative, negative. Ooh, I think that's where I made my mistake, isn't it? So when I originally did this one, I forgot to bring the negative with that 5, I think is what I did. So darn it. Very first one I made a mistake on there. So they should switch positions, but this 5 was negative to begin with. What's changing signs when I rotate 90 degrees? Oh no, it is 90 degrees counterclockwise. I think I did do it correctly. So it's -5. The Y. Okay, so yes, I did make that mistake because I think I switched this guy to positive, but I should have switched this to negative. So I made a big deal about paying attention to clockwise and counterclockwise, and then I switched the two darn rules, didn't I? So this one would actually work because here's -4, -5. So that one is the correct one here. It's not none of the above. It's that guy there. All right. So does everybody make mistakes? Of course everybody does. Just go back and try again. We just don't give up. All right. So that was section 1. I will see you in section 2.